In this lesson, we'll cover graphing points and equations. To start with, a point, which is sometimes called an ordered pair, is something of the form x comma y, where this is the x-coordinate and the y-coordinate of the point. We can graph this in the xy plane by going x units on the x-axis and y units on the y-axis. So let's plot the points here in example 1, starting with this one, 1, 3. I'm going to label this axis as the x-axis and this as the y-axis. And here, this is the point 1, 3. 1 is the x and 3 is the y. You start here. This is the point 0, 0. It's called origin. You go 1 in the x direction, so positive means you go to the right, so you go 1. And we're going to go 3 in the y direction, and a positive 3 means you go up. And so we get this point here. So the point 1, 3 has this location. Now, if we look at this one, -4, -2. Again, same idea. You start here at the origin, which is 0, 0. And we're going to go -4 in the x direction, so that's here. And then we're going to go down 2 in the y direction. So this point here is at 4, -2. So here is 0, -1. Where is this located? So again, we start here at 0, 0, the origin. Now we're not going left or right in the x direction, so we're done with that. But now we go down 1. And so this point is located right here. 4, 5, 0. So this time we go 5 in the x direction, and we don't go up or down because the y value is 0. And so the point 5, 0, this one, is located right here. The point 2, -2, starting here at the origin, we go 2 in the x direction and then -2 in the y direction. So this point is located here. This is 2, -2. And we have one point left that is -1, 2. That means we go 1, -1 in the x direction and then 2 in the y direction. Therefore, this point is located right here. And that's the basics of plotting points. Plotting these will allow you to understand how to plot or graph an equation. One last thing to add is this location right here, I was calling the origin. So I'd like to actually write that down. So right here, that is the origin, and its coordinates are 0, 0. Now let's expand on this idea of plotting points to graphing equations, like this one, y is equal to 2x plus 1. The idea is we have an equation that relates x's and y's. We can use this to get points to get our graph. Here's a very standard way to do this. We're going to create a table of values, a column for the x's and a column for the y's. We can choose a value for x, use this equation to find the corresponding y. That'll be a point that we can plot over here. You can choose whatever you want for x or whatever you want for y. That's entirely up to you. But just to keep it simple, I'll go maybe -2, -1, 0, 1, and 2. You can choose any numbers. I'm just choosing these. I mean, they're the simplest. Starting with this -2 for x, we can go to this equation, put -2 here, solve for y, and put that number here. Let's try it out. I'll do this off to the side. So if x is equal to -2, we would go to our equation, and wherever we see an x, we'll plug in -2, and then we just need to simplify this. Y is equal to 2 times -2, that's -4, and if you add 1 to that, you get -3. This means when x is equal to -2, y is equal to -3, so if we go to the origin, we go 2 to the left, we go down 3, and that's the corresponding point on this graph. So I will plot that here. Now, that's not enough points to understand what this graph looks like, but we have a few more. Maybe we'll get an idea after that. Okay, so now, all right, I'll say, well, what about for x is equal to -1? If I plug this into the equation, that is 2 times -1 plus 1. That is -2 plus 1, and -2 plus 1 is -1. So what this means is when x is -1, well, y is actually also -1. That is the point -1, -1, which is here. Do the same thing for 0. When x is equal to 0, let's see, y is equal to 2 times 0 plus 1, and well, 2 times 0 is 0, and if you add 1 to 0, you get 1, and so we have the point 0, comma 1, which is, if you start here, you don't go left or right, but you do go up 1 to this spot here. I'm starting to see a pattern. It looks like, well, if we connect these points, maybe we'll get something that looks like this. Well, let's see. I'll now choose x is equal to 1. If I put that into my equation, let's see, y is equal to 2 times 1 plus 1. That means y is equal to, well, that's 2 plus 1, or 3. Okay, so we get 3. That's the point 1, 3. That's here. And lastly, for 2, we'll use a different color. So that's when x is equal to 2, y is equal to 2 times 2 plus 1, which is 4 plus 1, and that's 5. So that's the point 2, comma 5, which is over 2, up 5, right here. Okay, I think I get a good idea of what this equation is going to look like. It's the graph going through these points. So I'll try to draw that as best I can. We get something that looks like this. These arrows just indicate that this is trending forever. But here it is. This is the basics of, if you're given an equation, something that connects x values to y values, you can set up a table to get points, plot a few of them, and then sketch the equation in around it. In the previous example, we had a line, but this method will work for any type of equation. So here's a different one. Y is equal to, well, this is called the absolute value of x, and then you subtract 2. So maybe just a reminder for this problem. So if you see this symbol, this is the absolute value. And what this does is, if you take a number like 5 and you put it into the absolute value equation, well, it takes a positive number and just leaves it alone. But if you put a number inside the absolute value that's negative, like maybe -7, it makes that negative become positive. So if you see this absolute value symbol, positive numbers just remain the same, but negative ones become positive again. So using this idea here, and maybe a table of values, I'd like to plot this equation just to see what it looks like. So here I'll create a table with some x's and y's. Again, you can choose any x values that you like. They either work or they don't. So I'll stick with, I don't know, maybe that -2, -1, 0, 1, and 2. Let's see what happens when x is equal to -2. Well, in the equation, that's the absolute value of -2 minus 2. Now first, the absolute value of -2 is 2. But then you're still subtracting 2, and 2 minus 2 is 0. So at -2, the y value is 0. This means you go 2 to the left, but you don't go up or down. We just get this spot right here, -2, 0. Okay, we need more if we want to get a pattern. So yeah, on to x is equal to -1. If I put this into my equation, that would be the absolute value of -1 minus 2. So let's see, the absolute value of -1 is +1. And if you subtract 2 from 1, you get -1. So here we have a y value of -1. So that means we go left 1 and down 1 right there. All right, I'll keep going. Let's see, what about x is equal to 0? So that would be y is equal to the absolute value of 0 minus 2. Now the absolute value of 0 is 0. It's not positive or negative, but it does equal 0. And if you subtract 2 from 0, you get -2. So at 0, we get -2. That means we don't go left or right, but we do go down 2 places to get to the y value. Let's see, we also have x is equal to positive 1. If we put this into the equation, that's the absolute value of 1 minus 2. Well, the absolute value of 1 is 1. And if you subtract 2 from 1, you get negative 1. So that's the corresponding y value, negative 1. If we plot this, let's see that's 1 in the x direction, negative 1 in the y direction. So that is right here. We have one last number that I chose, and that was when x is equal to 2. The corresponding y value would be the absolute value of 2 minus 2. The absolute value of 2 is 2. And if you subtract 2 from 2, you get 0. So for the last one, the corresponding y value is 0. That means you go over 2, but you don't go up or down. And so you get this spot right here. Now, this may or may not be enough to see the trend, but I think it's enough for me. I see for these 3 points, I bet the trend continues where it just seems to like be increasing in this direction like this. But the difference is on this side, it's not a line altogether because this side is going in a different direction. But if I connect the points, I think we get something that looks like this. You know, it's a decent sketch of what this graph probably looks like. But that is it for this example. A couple of definitions before we look at the last example here. Those are, to start with, an x-intercept and a y-intercept. Sometimes when you graph equations in the xy plane, the equation will equal the x-axis and possibly also the y-axis. So let's try to identify those places if they exist on the graph in example 4. So here's the x-axis. An x-intercept is wherever the graph equals the x-axis. And I see there's 2 places. There's a spot here and a spot here. So I'm going to label those. So here is 1. Here's a second spot where the graph actually equals the x-axis. Those are x-intercepts, which you can abbreviate x-int, like this. Those points, let's see if we can figure those out. Well, this point is 3 to the left, so it's negative 3 for the x value. The y value is 0 because you don't go up or down. So this point right here has the coordinates negative 3, 0. So this point is an x-intercept on this graph, whatever the equation happens to be. One thing to point out is that when you're talking about an x-intercept, the y value will always be 0 because you're not going up or down, but you're actually right on the axis, the x-axis itself. Now there's also this one here, and like I was saying, well, I know the y value has to be 0. That's always true for an x-intercept. What we really care about is, well, what's the x value? And the x value is positive 1. That's how far you move from the origin. So that's that spot right there. So here it is. This is the x-intercepts for this graph. Now, what about the y-intercept? If I'm looking at this graph, and this is the y-axis, I see that there is exactly one spot where the graph equals the y-axis, and that is right here. So I'm going to label that as well. So if we want to find the y-intercept, I can see that it's right here. There's only one. What are its coordinates? Well, the x value is 0. This will always be true for a y-intercept. The x value must be 0 because you don't go left or right. You're actually right on the axis. And the y value looks like it's negative 3. The other 2 definitions are domain and range. When we were plotting points, the first coordinate was an x value and the second coordinate was a y value. All of the x values on a graph is what we call the domain. So it's like a collection. And all the y values is what we call the range. So if we look at this graph, can we think about all the x values for all of the points? And then can we do the same thing for the y values? I'm going to start with the domain. If you look at all these points, what x values to get back? So like for example, is negative 1 in the domain for this graph? And the answer is yes. And the reason is it corresponds to this point here. Whatever this point is, it has an x value of -1, so I know -1 is in the domain of my equation. What about 0? Is 0 in the domain of my function? And the answer is yes, because this point here has an x value of 0. You also get everything in between -1 and 0, because all these points correspond to this part of the graph here. You also get everything between 0 and 1, because all of these x values correspond to these points. In fact, you get every single x value for this graph. Maybe for emphasis, I'll put a couple of arrows on here to indicate that the graph is moving forever in this direction. There is not a spot on the x-axis that will be missed. And so for this reason, the domain is all real numbers. It's everything. Now, even over here at 5, I don't see anything on the picture I provided, but if you go up far enough, eventually the graph will exist above 5. The same thing is true for 6 and -7 and everything. Now, what about the range, all of the y values that you get back for this equation? So what is that? What is the range? Do we get everything this time? So let's see, for example, is 5 in the range of this equation? Well, this point over here has a y value of 5, so the answer is yeah. 5 is in the range because there's this point over here whose y value is 5. In fact, it happens again over here. In fact, there's 2 points where you get 5 back for the y value. So it just has to happen once. If it happens more than once, that's okay. In either case, 5 is definitely in the range of this equation. Well, what about 4? For the same reason, 4 is in the range as well. You look over here, and you look over here. These are 2 points whose y value is 4. Therefore, 4 is in the range of this equation. And so is everything in between 4 and 5 because of all these points here and all these points here. In fact, since this graph is moving up forever, you get all these y values going up. And then you get all these y values going down here. But it actually stops at some point. Like, for example, here at -5, -5 is not in the range of this equation because if you look to the right and you look to the left, there's no points that it corresponds to. At 5, there were 2. But here at -5, there's nothing. Same thing is true for -6. You look to the right and left, the graph isn't there. In fact, the place where it stops appears to be right here. So if I label this y value is -4. -4 is definitely in the range because of this point here. There's exactly 1. There's absolutely nothing below it, but we get everything above it. So for this reason, the range is every y value that's greater than or equal to -4. So here we had an x and a y intercept. If you include all of the x values, we call that the domain. If you include every y value, we call that the range. And that's it for this problem.